In the previous videos, we have introduced how to use pthread API and C++ API. As you may see, a lot of code is written for managing the thread rather than implementing the program logic. For many applications, the thread management tasks are very similar. So is there a way to automate this process? Yes, MPI is a solution that can help developers to create threads and manage data communication across threads. MPI stands for Message Pathing Interface. It defines a standard API for threads or processes to pass messages. In this video, we focus on thread creation, and in the next video, we will demonstrate how to let the threads to communicate. Let's start with a Hello World example. First, we need to include the definitions from the mpi.h file. An MPI program still needs the main program. However, the concept of this main program is slightly different from a regular C or C++ main program. An MPI program has multiple copies of the main program running. Each copy runs as a thread or a process. The number of threads is not decided by the programmer, but by the user at runtime. We will see that later. In the main program, a few functions need to be called. First, we call the MPI init function. The function initializes the environment. Developers need to pass the pointer to argc and argv to the MPI init function. The MPI init function processes command line argument and will remove the argument consumed from the argument list. That is why this function needs pointers. Once the environment is initialized, we can start working on the program. We first need to know how many threads are created in total and the index of the current thread. The API MPI com_size function provides the total number of threads. A thread, in MPI terminology, is also called a rank. The word com is short for communicator. By default, we use the MPI com word communicator, which includes all the ranks created. So next, we can call the MPI com rank to get the index of the current rank. Different threads may do different things, so this number will determine the thread action. Next, let's print something as a demonstration that the program works. If you want to change this Hello World example to an extra program, you should replace this line to your program logic. At the end of the program, we will need to call MPI finalize to clean up the environment. Here is a full list of the program. We include the MPI header and cause a series of APIs to start the program. Next, we will see how to compile and run the program. To compile the program, we cannot use the regular GCC or G++ compiler. We can use the special MPI-CC compiler. You would need to install the MPI runtime environment on your computer to be able to use it. The compiler is named MPI-CC, so you can use this command mpi-cc-o main.cc to compile your MPI program. The compiled executable file is main in this case. To execute the MPI program, we cannot directly run the program. We need to use MPI run program to bootstrap the OR program. The MPI run program takes many arguments, but one of the most important arguments is -n, which is the number of threads to create. Remember, we do not need to create threads in an MPI program using either the pthread API nor the C++ thread API. The MPI execution environment will do it for us. In fact, MPI is very powerful, and the thread of this program can even execute on different machines. The execution of the Hello World MPI program is shown below. We see that as we run 4 threads, 4 messages are printed. Note that it is a coincidence that these prints are in order. Parallel MPI program execution cannot guarantee the order.